Good afternoon, everyone. Welcome back to Visual Tuition Program of KZN Department of Education. We are here with our second lesson for mathematics. Last time when we were together, we were dealing with the functions, which we did the parabolic function. So today we will be continuing with our lesson. The first part of the lesson will be done by myself, Mr. Nzama, and then the second part of the lesson will be done by Mr. Ntuli as usual. So last time when we were together, we did this topic, which is called the functions. As we all know, the functions, they amount to 35 marks in your examination. So it's very important that you do very well in this section. So without wasting any time, I would like us to start by looking at a hyperbolic function, because last time we were doing a parabolic function. So in terms of the hyperbolic function, it is given by this equation, which is y equals to a over x plus p plus q. So this is your general form or your general equation for a hyperbolic function. It's also very important to take note that this function comes from this mother graph or mother function, which is in the form of y equals to a over x. Last time when we were together, we spent a lot of time discussing the parameters, the effect of P as well as the effect of Q, on what is it that they do to the graph. We said the effect of P, when we say plus P, it means now our graph will then shift to the left by a certain number of units. So P affects the graph in terms of the horizontal shift. So, and then we also said Q affects our graph in terms of the vertical shift. If you shift your graph vertically up or down, then Q will also then affect the graph. So if Q is positive, then the graph will shift upwards. If Q is negative, then the graph will shift downwards. So we spent a lot of time in our previous lesson talking about the value of P or the effect of P as well as the effect of Q. So that is our general form for the hyperbolic function. Now, our hyperbolic function may take form in this way when our A is positive, or it may take this shape when our A is negative. So when our A is positive, when our A, the value of A is positive, then your graph will then be located in the first as well as the third quadrant. That's when the value of A, if it is positive. And then when the value of A is negative, then the graph will then focus in the second quadrant as well as in the fourth quadrant. So it's very important to take note of that the value of A affects the graph in that way. If A is positive, then your graph will be found in the first quadrant as well as the third quadrant. And then when A is negative, then your graph will be found in the second quadrant as well as the fourth quadrant. So it's also important to take note of that one. I will then move and then talk about the vertical asymptote as well as the horizontal asymptote, because each and every graph will have its own characteristics. And the characteristics of a hyperbolic function is that it will have what we call the vertical asymptote as well as the horizontal asymptote. It will have the vertical asymptote as well as the horizontal asymptote. Now, what is it? What is the asymptote, in fact? What are the asymptotes? Because in this graph, we are saying we have a vertical asymptote as well as the horizontal asymptote. So the asymptotes in terms of the graphs are the points at which the graph approaches, but the graph obviously will never reach those points. So if we have this type of asymptote, because it is a vertical line, we say it is a vertical asymptote, but then we also have this type of asymptote, which is then now called the horizontal asymptote. So the value of P in our equation, remember we said our equation is in a form of y equals to A over x plus P plus Q. Then the value of P, when you take this x minus x plus p, you take this x plus p, you equate it to 0, then you get your asymptote in a form of x equals to minus p. Then what does this asymptote represent? This asymptote then represents your vertical asymptote. It is the vertical asymptote. It is the line which will be drawn in a form of a dotted line to indicate. Then you must also indicate this line as your vertical asymptote, which will be x equals to, depending on the value, then x will be equals to a particular value. So if this is maybe positive 1, if this is positive 1, then the asymptote will be written as x equals to positive 1. So it's important to take note of that one. Our hyperbolic function has the vertical asymptote as well as the horizontal asymptote. Then the value of q in our equation, the value of q in our equation then represents what? The value of q represents the horizontal asymptote. The value of q represents the vertical asymptote. Yes. The value of q represents the horizontal asymptote. So we take the value of q as it is. So our q, our y will be equals to q, which is now what? We call it the horizontal asymptote. So as I said, in our graph, we'll be having a horizontal asymptote as well as a vertical asymptote. Then another thing that is critical and important, just like any other graph, before you sketch the graph, you will then have to do what? You will then have to calculate the x-intercept as well as the y-intercept. You will then have to calculate the x-intercept as well as the y-intercept. And then after doing that, you will then be able to determine, after sketching your graph, you will be able to determine your domain. And the domain in the hyperbolic function is always x as an element of all real numbers, because your graph will reach any other possible value of x, but except the asymptote. We always have to exclude the asymptote. Whenever you are writing the domain as well as the range of a hyperbolic function, you must then do what? You must say it's x is an element of all real numbers, but you must then exclude your asymptote. But we'll get to that when we have sketched our graph so that you can see it graphically. What does it mean? And then moving on to our equation here, we have an exercise that we need to do together. We have this equation. We have this equation. We have this equation here, which is y equals to 2 over x minus 2 plus 1. Remember, I said to you, the value of p as well as the value of q represents our horizontal as well as the vertical asymptote. So it's very important to write your equations of asymptotes first, because that's what you are going to need when you start sketching your graph. So our q here, our q is 1. So it means the equation of asymptote, our first equation of asymptote is y equals to 1. And then we also have another equation of asymptote, which will be our vertical asymptote. It will be x equals to 2, which comes from what? It comes from that part there, which is our x minus 2. We then said we'll need to equate our x minus 2 to 0 and solve for x. So our equation of asymptote will then be x equals to 2. It will be x equals to 2. That will be our equation of asymptote. We then now need to calculate the x-intercept as well as the y-intercept. We then need to calculate the x-intercept as well as the y-intercept. Let me change some color. We are now calculating the x as well as the y-intercept. So for the x-intercept, number one, for the x-intercept, we did indicate, because the x-intercept is found along along the x-axis, where line y is equals to 0. Because along the x-axis, y is always equal to 0. So as we are calculating our x-intercept, we'll then go to our equation. Where there is y, we are going to substitute 0. We are going to say 0 is equals to 2 over x minus 2 plus 1. So this is now our equation. We then have to solve for x so that we get the x-intercept. We are then going to transpose this one to this side, and then it's going to be -1 equals to 2 over x minus 2. And then what we are going to do now, we are going to cross multiply because we want to find the value of x. Then we are going to say -1 times x, which is going to give us -x. Then -1 multiplied by -2 is going to give us +2, which is going to be equals to 2 multiplied by 1. It's going to be 2 again. And then we are left with -x plus 2 equals to 2. We are then going to do the same thing as we did before. We're going to say 2 minus 2. We are going to transpose this one, and then it's going to change its sign. Then we are now going to have -x equals to 0. And then we are going to do what now? We are going to divide by negative so that our x becomes positive. And then it means our x will be 0. We then have to calculate the y-intercept. We have to calculate the y-intercept. Let me change colors. For the y-intercept, it's going to be the same thing. The y-intercept is found along the y-axis. So if it is found along the y-axis, on the y-axis, x is always equals to 0. So we are going to say x is equals to 0. Then we are going to go to our equation, where our equation is saying y is equals to 2 over where there is x, because our equation is x minus 2 plus 1. Then where there is x, we are going to substitute 0. Then our y-intercept will be then equals to 0 again, because 2 divided by -2 will give us -1. Then -1 plus 1 will give us 0. So it means our y-intercept is also 0. So now it means we have the x-intercept as 0. We also have the y-intercept as 0. We now have to sketch our graph because we have calculated the x-intercept, the y-intercept. We also have our equations of asymptotes. So what is left for us is to sketch our graph, because we have everything that we needed. We needed the x-intercept, the y-intercept, the equations of asymptotes. Also, please bear in mind that the value of A, we said it determines the shape of the graph. So our A here, we can see our A is greater than 0. So we said if A is greater than 0, then your graph will then be in the first, as well as the third quadrant. Because our A is positive, our graph will be in the first as well as the third quadrant. Please remember, we said our x-intercept is 0 and our y-intercept is 0. So it's now time for us to sketch this graph. As we are sketching the graph, please remember to write your comments, ask any questions on the question and answer section in your screen. If you feel that maybe you need to make a comment or you need to ask anything, please feel free to ask those questions. Please also remember to fill in the register. There is also a register on that comment section. So now we are sketching our graph because we have everything that we needed. So it's time now for us to sketch the graph. It's time now for us to sketch this graph. We'll start by indicating the equations of asymptote. Now we are going to look at our equations, then we are going to draw the asymptote here. So our first equation, which is the horizontal asymptote here, Our horizontal asymptote is y equals to 1. So our y is equals to 1. So we are going to indicate our asymptote using a different color so that you all see that this is our horizontal asymptote, which is y equals to 1. I'm then going to use a different color again to represent my vertical asymptote, which is x equals to 2. Here is our vertical asymptote. We said it's going to be x equals to 2. Remember, we calculated our x as well as y intercept, and the values that we got was 0 as the x-intercept, and we also got 0 as the y-intercept. Remember, we said our graph will focus on what? On the first quadrant as well as the third quadrant because of the value of A. The value of A is positive. So our graph will then focus in the first quadrant as well as the third quadrant. But obviously, it's going to move a little bit into the second quadrant and also into what? Into the fourth quadrant. Why? Because the graph shifted by 1 unit vertically up and it also shifted by 2 units to the right. So that's why now you are going to see the shape which looks like this. Now you can see that your graph is now a piece of your graph is on the second quadrant and another piece of your graph has moved to the fourth quadrant because the graph shifted by 2 units to the right and it's also shifted by 1 unit vertically upwards. So this will be our hyperbolic function. So this is how you sketch a hyperbolic function. The first thing that you do, you look for your asymptote, equations of asymptote, y equals 2, which is your horizontal asymptote, and x equals 2, which is your vertical asymptote. You then calculate the x-intercept, the y-intercept. You look at the value of A. It will tell you where your graph will focus. Then we can move to the next activity together. Please make sure that you write those questions or those comments if you feel maybe there's something that we also need to emphasize. Please make sure that you write those comments. Now we are going to be moving to the next activity, which is activity 2. Which says we must look at the sketch, which is below. The sketch below shows the graph of f. The sketch below shows us the graph of f. There is a graph of f, which is f at x equals to -9 all over x minus 1 minus 2. So when you look at that equation, it tells you that it's an equation of a hyperbola because it's in this form. It tells you that it's an equation of a hyperbola. So y equals to -9 over x minus 1 minus 2. A is a point of intersection of the asymptote. We are told, we are given the value there. We are given A as what? As the point of intersection of the asymptote. So this is where our asymptotes meet. A is that point where our asymptotes meet. So we obviously somewhere we'll have to find the coordinates of A because that is where our asymptotes meet. And then when you look at your graph, you can see that it is in the second quadrant and it is also in the fourth quadrant, as you can see. It is found in these 2 quadrants, but obviously it has moved a little bit to the third quadrant because of the shifting of the graph. So here, the first equation that we'll look at the vertical asymptote. When you look at this part, x minus 1, we said for us to get the equation of the asymptote, we say x minus 1 equals to 0, and then we solve for x. Then our equation of asymptote, the first equation of asymptote that we have, which is our vertical asymptote here, as you can see, this is our vertical asymptote. It is x equals to 1. We are then going to look for our horizontal asymptote, which is the value of q. So we are going to go into our equation and look for the value of q. So the value of q, there it's y equals to -2. So it's y equals to -2. That is our horizontal asymptote. So we know that this asymptote here is y equals to -2, and this one here is x equals to 1. By then doing that, we have answered the first question, which says, write down the coordinates of what? Of A. We have answered that question. Write down the coordinates of A. We were told that A is a point of intersection of what? Of the asymptote. It's where your asymptotes meet. So it means the coordinates of A, we already have the coordinates of A. So the coordinates of A are X is 1 and Y is -2. So that's how you will then do that question. Now let us move to 2.1.2. 2.1.2 says we must determine the x coordinates of the x as well as the y-intercept of f. So we must calculate the x-intercept as well as the y-intercept of f here, the x-intercept as well as the y-intercept of f. I think we have covered that one even in our previous question when we were sketching the graph. So now they want us to determine this part here where the graph cuts the x-axis and this point here where the graph cuts the y-axis, which is our x-intercept as well as the y-intercept. So it's very simple. For the y-intercept, the y-intercept is a point that is found along this line, the y-axis. And we know that x along that line is always equals to 0. So ours is to go into our equation where there is x, then we substitute 0. So our equation is x minus 1 minus 2. So we'll then substitute 0 where there is x. So it's 0 minus 1 minus 2. Then our answer will be negative. No, negative will give us positive. So it's plus 9 minus 2. So it should give us positive 7. So that will be your y-intercept. So x will be 0, then y will be 7. So that should be our y-intercept. We then need to calculate, as the question is asking us, we then need to calculate the x-intercept. And for the x-intercept, because the x-intercept is a point that is found along this line. So along this line, y is always equals to 0. Y is always equal to 0 along this line. So the x-intercept, then y will be equals to 0. Then we'll go to our equation again, where there is y, we'll then substitute 0. Our equation of x equals to -9 over x minus 1 minus 2. So y will then be 0. Then we have -9 x minus 1 minus 2. And then we solve for x. We then transpose our -2. It will be positive. We move -2 to the other side. It will be +2 minus 9 over x minus 1. And then after that, we have to do what? We need to do our cross multiplication. We need to cross multiply. So 2 multiplied by x will give us 2x. 2 multiplied by -1 will give us -2. Equals to -9 multiplied by 1 will give us -9. We are then be left with 2x. We then transpose our -2 again to this side. It will then be 2x. It will be 2x equals to -9 plus 2. Then 2x will be equals to -7. Then we have to divide by 2. Then if you divide by 2, we'll have x equals to -7 over 2. We'll have -7 over 2, which is what? Which is 3,5. Then x is -3,5. Because if you wanted to sketch your graph, you will have to know the value, the decimal value, so that you know it's between which two integers. So in this case, you could have left your answer as -7 over 2 or -3,5. So I think we have answered the question. Then the coordinates then will be -3,5 as well as 0. So these are your x-intercept. We then move to the next question. Which is 2.1. 2.1 says we must determine the axis of symmetry that has a negative gradient. This question is very important. You always find it in hyperbolic functions where they say you must calculate or you must find the equation of symmetry. Remember, when we were doing parabolic function, we did speak about the equation or the line of symmetry. In a parabola, we said the line of symmetry divides our parabolic function into two symmetrical parts. Even here in our hyperbolic functions, we do have two lines that divides our graph into two symmetrical parts. One line has a negative gradient and the other one has a positive gradient. So here we are told that we must then determine the equation of the axis of symmetry with a negative gradient. It's very important to take note of this. The axis of symmetry with what? With a negative gradient. And the axis of symmetry with a negative gradient will be a line in this form, a decreasing line, because when we say it has a negative gradient, it means that line is decreasing. So it will be a decreasing line. And then a decreasing line, and again, what is important is that the line of symmetry or axis of symmetry in a hyperbolic function passes through the point of intersection of your asymptotes. Where your asymptotes meet, it's where your line of symmetry passes. So it passes through the point of intersection of the asymptotes. So in other words, it means we already know the point where our equation or our line will pass, because we know the coordinates of A, or we may be able to calculate the coordinates of A, because the coordinates of A are our equations of asymptote. Maybe let us remind ourselves what were our equations of asymptote. Y is equal to -2. We said Y is equal to -2 because our Q is -2. And then we said we will say X minus 1 equals to 0. Then X is equals to 1. So our equation of symmetry number 2, it's X equals to 1. So the coordinates of A are 1 as well as -2. So it's important to take note of that one. So in other words, it means now we may be able to now determine the equation that is being required from us. Because for a straight line, if you are looking for an equation of a straight line, you just need two things. You just need to know the gradient of the line. You also need to know the point found on that line. So we already have the point which is on this line. Then what is left now is for us to determine the equation of symmetry. The equation of symmetry will be in this form: y equals to mx plus c, which is your equation of a straight line. Or you may say y equals to, I like this one, y equals to plus or minus x plus p plus q. You then now have to substitute your P, and then you also substitute your Q. Then you will get your equation of symmetry. Now, when we say y equals to, now, because we were told that we must find the equation of symmetry with a negative gradient. So for ours is to choose between here, between this positive, this plus or minus. We must then choose which gradient are we using. We are told it's a negative gradient. So if it is a negative gradient, then we must then decide which one we are going to choose between a plus and a minus. So it's going to be minus into x. Remember, our P is the value of what? Is the value there that we said it's x equals to 1. So here is our P, in fact. Here is our P. X minus P. This is x minus P. So here we are going to say x minus 1, because our P there in our equation, you can see that your P is minus 1. So it's going to be x minus 1. Then the Q, it's minus 2. So you just take it as it is from your equation. The value of P was minus 1 and the value of Q was minus 2. And then we are now going to do what's just simplify here. Then we are going to distribute this negative multiplied by this, it's negative x, negative multiplied by this, it's going to be positive 1, then minus 2. Then our equation will then be y equals to negative x minus 1. So this will be our equation of symmetry with a negative gradient. Our equation of symmetry with a negative gradient. So it's important to take note of this formula, because we always use this formula to determine what? To determine the equation of symmetry. Y equal to plus or minus into x plus p plus q. So let's say maybe the question was asking us, let's say the question was asking us to find the equation of symmetry, but with a positive now, with a positive, not a negative, with a positive gradient. We were going to do the same thing. If the question was asking us to calculate or to determine the equation of symmetry with a positive gradient, we're going to do the same thing. We're going to say y equals to, but we're going to choose positive now, because here it's supposed to be our gradient. We're going to say positive now because we're looking for a line of symmetry with a positive gradient. And then x, our p from the equation was -1. We're going to say -1. Then our q was -2. And then we're going to simplify our equation. Positive times x, it was going to be positive. Positive times this -1, it's -1 minus 2. Then our equation was going to be x minus 3. So in other words, you must know, you must expect a question to ask with a negative gradient or with a positive gradient. But you are going to use the very same formula, which is this one. Let me highlight it again. It's this one. It's this formula here. It's this formula here. I'm trying to highlight it so that we all see it. It's this formula here. Y is equal to plus or minus into x minus into y equals to plus or minus into x plus p plus q. So when it's a negative gradient, then you take negative and then you just substitute the value of p as well as the value of q from your equation. You just take it as it is from your equation. Moving on to the next one. The next question is asking us if the graph of f is reflected about the x-axis. They are saying the graph of f is reflected about the x-axis. So let us look at our graph here. This is the graph, and then we are told that it is reflected about the x-axis. Now we have different types of reflections. It's important to take note of that one. We have different types of reflections. Now we are told that this one here has reflected about what? About the x-axis. To obtain a new graph of G. So we are going to have a new graph of G, which we are told that then we must write down the new equation of G in this form, in a form of y equals to. We must then write down the new equation of G in a form of y equals to. So for us, it's very simple. When you are saying something is reflected about the axis, at the x-axis, we just look at your x-axis here. Here are your x-axis. So when we say something is reflected about the x-axis, it means it is moving from this point to this point. And you know, when you move from this point to this point, from the first quadrant, in fact, to this fourth quadrant, you then what? The value of x will then change in terms of its sign. So when you reflect about the x-axis, the value of y will change, not the value of x. I made a mistake. The value of y will change its sign, not the value itself, but the sign will change from a positive, because here it's positive, to a negative. So when you reflect about the x-axis, y changes its sign. So when you reflect about the x-axis, so y will change its sign to be a negative. So you simply put a negative sign where there is y. It's as simple as that. So let us go to our equation. They said we must write this equation. We must write this equation as y equals to, it is now going to be our new equation, which is G, but they said we must write it in a form of y equals to. So as I said, when you reflect about the x-axis, when you reflect about the x-axis, what changes? What changes when you reflect about the x-axis is the sign of y. The sign y will change and become a negative. So here we are going to have negative into negative f at x, or negative y, equals to -9 over x minus 1 minus 2. So that's how we are going to start it. So where there is y, because we are reflecting about the x-axis, then y changes its sign. And then we are now going to make y the subject of the formula here, because we must leave our equation in the form of y equals 2. So it means we must then do what? We must divide by this negative. So remove this negative here, we must then divide our equation with negative. So when you divide by -1 or negative, you are left with f at x equals to -9 over x minus 1. Because I'm dividing all of this by -1, I'm dividing even this term by -1. So it's going to be -2 divided by -1. So which is going to do what then? This will now change our sign for 9. We are now going to have a new equation, which is y equals to this -9 divided by that -1. It's now going to change to be 9 into or over x minus 1 equals to plus +2. Plus +2, because -2 divided by -1 is going to be +2. So it means our new equation in this form, in a form of y equals to, our new equation will be y equals to 9 over x minus 1 plus 2. Because the value of a is going to change its sign because we divided by a negative, and then the value of q as well, which was 2, will change. So our new equation is y equals to x minus 9 plus x minus 1 plus 2. So our equation is y equals to 9 over x minus 1 plus 2. So that is our new equation, because our graph was reflected about the x-axis. So what will happen if we reflect now about, let us reflect it about, the y-axis. The question was asking us to reflect it about the x-axis, but let us reflect it about the y-axis so that we see the difference. Now, if we were asked to reflect this graph about the y-axis, so when you reflect something about the y-axis, because your y, this line here, this line y, this line here becomes your mirror. So it means something will change from being, the value of x will change to a negative. So when you reflect now about the about the y-axis, when you reflect about the y-axis, then x will change its sign and become a negative. So x will change to a negative. Then in your equation, so it's very simple, you are going to go where there is x, you simply put a negative sign. So instead of having a positive x, we are now going to have a -1. Let me quickly move to the next one. The sketch below shows the graph of f. Again, it's the same graph, but now the question is asking us, because here we are trying to interpret, this part is called the interpretation. We are trying to interpret the graphs by answering these questions. We already have the graph sketch for us. So for us now is to try and interpret this graph. For which values here, we are asked for which values of x will this graph f at x be less than or equals to 0? So it's a very simple question. You just have to go to your graph and look where f is less than or equals to 0. The question is asking for which values of x, will f at x be less than or equals to 0. So ours is to know what is something that is less than 0. What do we call that thing? We call it a negative value. So if it is less than or equal to 0, if it is less than 0, so it means it is negative. So we want to look at our graph where our graph is negative, where our graph is less than 0, or where our graph is 0. So that is our condition. We are looking at the values of x. We want to know the values of x where our graph is less than or equals to 0. So if you read your graph from left to right, you know your graph will be less than 0, below this line, below the x-axis. So our graph is less than 0 below the x-axis, and it is greater than 0. It is positive. In fact, when you say it's less than 0, it's negative. Then when you say it's greater than 0, it's positive. So we are going to look at the point where our graph is less than 0. So it means we are going to look at the point where our graph is below the x-axis. So our graph is below the x-axis here. You can see that when you read your graph from left to right, it is below the x-axis. And at this point, the graph is 0. But when you move up, the graph becomes positive. So from this point, going upward, the graph of f is greater than 0. So we are not looking for this part because it does not meet our condition. So we want to see where the graph is less than 0 and where the graph is 0. So it's clear to see that when you read your graph from left to right, at this point, the graph is less than 0 because it is below the x-axis. So for ours is to know this point here, because at this point, the graph is 0. And then when you read it from left to right, then you can see that it is below the x-axis. So it is below until it reaches that point, which is what? Which is called our x-intercept. So from negative infinity to the x-intercept, the graph is below until it is 0 at the x-intercept. And here, when you read your graph from here, from this point, you can see that the graph is also below the x-axis. So even at this region, our graph is below the x-axis. And we know the equation of asymptotes here at this point, that the equation of asymptotes is x equals to 1. So for all values that are greater than 1, the graph is less than 0, is less than or equal to 0. So one of our answer or our possible answers is when x, because all these values are greater than our equation of asymptotes, they are greater than 1. So this is one of our answers. At this region, our graph is less than 0. And also we said from this point, from this direction, you can see that the graph is below the x-axis until it reaches the x-intercept. So for us is to know the value of the x-intercept, then we will be able to calculate, to determine which values of x. Then the x-intercept, we said y is equals to 0. For x-intercept, when you are looking for x-intercept, y is equals to 0. So in our equation, we're going to say y equals to 0, then minus 9, x minus 1 minus 2. It's something that we already calculated. And then you're going to transpose 2, negative 9 over x minus 1. Then you cross multiply. Then you have 2x. Then you'll have 2x. We have calculated the x-intercept even in our previous questions. You'll have 2x, 2 multiplied by negative 1, it's negative 2, equals to negative 9 times 1, it will be negative 9. Then 2x equals to negative 9, you transpose this 2, it will be positive 2. Then we'll have 2x equals to negative 9. Then we divide by 2 on both sides, then x will be equals to negative 7. Sorry, it should be 7, negative 7. Here it should be negative 7, not negative 9. It should be negative 7 over 2, which we said it's negative 3,5. So it means the value here is negative 3,5. So our second answer will be x must be less than or equals to negative 3,5, because we were looking at this point, the value of the x-intercept. And we know that all the values that are on the left-hand side of negative 3,5, they are all less than that value. So the second answer should be x is less than or equals to negative 3,5. I hope you are still following. please make sure that you do send those comments, you do ask those questions where you feel maybe we need to explain further. Right, let us move on. We'll now be looking at our exponential graph. I hope you have captured everything that you needed to capture in terms of the hyperbolic function. We are now going to be moving to the exponential graph. And then the exponential graph comes in this form. The exponential graph will come in this form. It comes in this form. It's come in a form of y equals to a times b to the power of x plus a plus a equals in the form of y equals to a times b to the power of x. Again, in the form of y equals to a times b to the power of x plus p plus q, where x and where p and q, as we have already indicated previously, p and q, they represent both the horizontal as well as the vertical shift. Right. Again, you will find that a again do tell us about the shape of the graph. A will also tell us, together with B, they will tell us about the shape of the graph. A together with B, they will tell us about the shape of this graph. And the shape of this graph can be an increasing function, as you can see here, when your B, because the value of B, when it is greater than 1, then your graph will then be increasing. When the value of B here, when the value of B is greater than 1, then your graph should be increasing. But when you look at the other part, when the value of B is between 0 and 1, meaning when the value of B is a fraction, any value that is between 0 and 1, a fraction, but obviously a proper one, will then be decreasing. When the value of B is between 0 and 1, any number that is between 0 and 1, that will be your half, that will be 1 over 3, that will be your 2 over 3. Any number that is between 0 and 1, if the value of B is between 0 and 1, then your graph will take a decreasing shape. Maybe let us sketch the graph so that maybe we'll understand it better, or you'll see what we meant when we say the shape of the graph. If B is greater than 1, then the shape of the graph will then be increasing. And if B is between 0 and 1, the shape of the graph will then be decreasing. Now, sketching this graph will require us to do the very same thing. It will require us to calculate the x-intercept as well as the y-intercept. But it's very also important to note that this graph has what we call the horizontal asymptote. Remember, when we were talking about the hyperbolic function has two asymptotes. It has the horizontal asymptote. It also has the vertical asymptote. But this one here, it only has one asymptote, which is called the horizontal asymptote. But as we are going to be sketching this graph, you are going to see what I mean when I say it has the horizontal asymptote. Let us sketch our graph together. We are going to calculate the x-intercept as well as the y-intercept. We are going to sketch this graph. We need to calculate the x-intercept as well as the y-intercept. We have to calculate the x-intercept as well as our y-intercept. For the x-intercept, y is equals to 0. So we'll go to our equation where there is y. We are going to substitute 0. Y is 0. For x-intercept, y is equals to 0. So it will be 0 equals to 2 to the power x minus 1. Then we are going to solve for, x. So it's going to be 2 to the power x minus 1. Then we are going to transpose our 1. It will be positive 1 equals to 2 to the power x. Then we have now 1 equals to 2 to the power x. Then what is left for us? We can do two things here. We can try to use logs to make our exponent the subject of the formula, or we can then try and make our bases the same. So we know anything raised to the power of 0 is 1. So for us now is to change this 1 and write it as this base, which is 2. We are making our bases the same so that we can then now drop the bases and equate the exponents. So x is equals to 0. Now our x is equals to 0, so that will be our x-intercept. That will be our x-intercept, 0, 0. Then let us calculate the y-intercept again. When you calculate the y-intercept, you do the same thing. For y-intercept, our x should always be equals to 0. So we are going to say f at x equals to 2 to the power of 0. Where there is x, we substitute 0, then 2 to the power of 0 minus 1. Anything raised to the power of 0 is 1 minus 1, which will give us 0. So the y-intercept is also 0. So it means our graph passes through what? It passes through a point where x is 0 and where y is also 0, because our x-intercept as well as our y-intercept is 0. Then we also have the equation of asymptote. We said in this graph, we have a horizontal asymptote, which is the value of q. So you can see in our equation, f at x, our value of q here. If you look at the value of q, this is the value of q. Our value of q is -1. Then this will mean our equation this will mean our equation of asymptote. Our equation of asymptote is y equals to -1. So it's important to take note that in an exponential graph, you have the horizontal asymptote. So we are now going to sketch this graph. Sketching this graph will require us to first indicate our asymptote here. We said the equation of asymptote is -1. So let us indicate our equation of asymptote, which is y equals to. So this is a horizontal asymptote. And then it's our -1 here. It's supposed to be -1. Okay. Sorry about that. Yeah. So this is our -1 here. Then we are going to plot this point, which is 0 and 0. Now we have plotted our point. Remember, we said our graph will take either an increasing or a decreasing shape. It will depend on the value of A and B. So our A is positive here. So the graph, our A, because our A is positive and our B is greater than our B, the value of B, which is 2, is greater than 1. So it means our graph will take this shape because B is greater than 1. So it will be an increasing type of a function. But if our B, we said if our B is between 0 and 1, then our graph should decrease. But in this case, our B is 2. So our graph is going to do what? It's going to increase. So if you know the shape of the graph, then you know that your graph will increase and it must not touch the asymptote. Then that's how you were going to sketch our graph. But sometimes you may find that you will be required to have at least 2 points. If you are required to have at least 2 points, in fact, it is advisable to have at least 2 points because our equation is given by f at x. our equation is given by f at x equals to 2 to the power x minus 1. So, and our domain is not restricted. So we can simply substitute maybe 1 where there is x. In our domain, we substitute 1. Then you get another point. It will be 2 minus 1, which will be y equals to 1. Y will be equals to 1. So another point on our graph would be when x is equals to 1, then y is also equals to 1. Right. I hope we are all following each other. Please make sure you write those comments and make sure that you fill in that register. So let us do our last question in this session before I allow my colleague to take over. We are going to look at this sketch here where we need to interpret this graph. We are given this graph here, which is an exponential function. You can all see that our exponential function is given by f at x equals to 1 over 3 to the power of x. So we are given the function. We are also given the shape or the sketch of this graph. So the first question is asking us to write down. So it's a question that we must make sure that you get these marks because it's an easy question. It is asking us to write down the domain of this graph. And we know when we are looking at the domain, you are looking at your x values. So we are asked about the domain of this graph. So when you read your graph, you read it from left to right. So we want to know, where is our graph starting in terms of the x values? And as you can see, there is that arrow. So it means the graph, we don't know where it is starting. And when you look at the graph as it continues, we don't know where it's ending. In fact, for the exponential graph, the domain does not change. It's always x equals to x is an element of all real numbers, unless maybe there is a restriction somewhere. But as long as there is no restriction, the domain of an exponential graph is from negative infinity to positive infinity. We don't know where it starts and we don't know where it ends in terms of the x values, the possible x values in our graph. So it's always the case. It's negative infinity to positive infinity, or x is an element of all real numbers, unless maybe there is some sort of a restriction. Then the next question is asking us to write down the equation of asymptotes of f. We spoke about the asymptote. We said in our exponential graph, the asymptote is represented by the value of q. So our given equation here, is f at x equals to 1 over 3 to the power of x. So you can see that there's supposed to be a value of q here, which is our constant. So in our equation there, you can see that there's none. So it means the y, or the horizontal asymptote, the equation is y equals to 0. So it means our equation is y equals to 0. So that's how you go about approaching these types of graphs. We've done the exponential graph. We've also done the hyperbolic function, and a week ago we did parabolic function. So I think it's important that we take note of the characteristics of these graphs, look at each graph, then draw down where the characteristics. For a parabola, this is what I need to know for me to sketch this graph. For a hyperbolic function, this is what I need to know for me to sketch this graph. Also for an exponential graph, this is what I need to know for me to sketch this graph. We've also done some interpretation. We spoke about the value of P as well as the Q, the effect of P, that P tells us about the horizontal shift, where if P is negative, the graph will shift to the left, to the right. If P is positive, it will shift to the left. And then when Q is positive, it will shift vertically upwards. And if Q is negative, it will shift vertically downwards. Maybe let me pause here and allow my colleague, Mr. Ntuli, to take over. Thank you very much for your time. Mr. Ntoli, over to you.
Yay. Welcome back. It has been a while. Here we are now. I want to believe that you had a very informative session with my colleague here, Mr. Nzama. So now we are going to look at a very interesting chapter, and a very interesting chapter of today. It is trigonometry. We all know that in paper 2, we have got just few chapters, but they've got marks. And it is this chapter that has got a lot of marks for us. So I'm inviting everyone to please call umakhelwane wakho ukuthi now we are here for the chapter that has got a lot of marks, which is trigonometry. It amounts for 50 marks out of 150. So if you can make sure that what we are going to deal with today, you master each and every concept, believe me not. This is one of the paper 2, which is easy. Why am I saying it's easy? Because everything, it's exactly as it is. As long as you know the theorems, you know the identities, then you are done. So without the waste of time, let me take you through these trigonometries I've alluded to. However, I'm going to start to look at what other diagnostic report has reported to us. In one of the year whereby students actually they said for their paper, this is what they actually, markers and the moderators they came up with. They said to us, some of the students, they must understand that in mathematics, you don't learn mathematics in silos. Hence, we are then expected to apply the knowledge across, they call it interdisciplinary approach in learning. I used to say there is a king of mathematics, which is algebra. So everything that we do mathematically, we are applying algebra. So it was also evident that as the students were writing their papers, they actually demonstrated to have the poor basic understanding, which is the foundational competencies that needs to be learned and understood by all the learners. So it is on those bases that we must make sure that whatever that we are doing, we really understand what you are doing. So there's key in passing mathematics with flying colors. It is on bullet number 4, whereby everyone is expected to have a conceptual understanding on the learning. So it is very important because, yes, calculators, we need calculators, but I always say, if calculators are what actually teach us, why do we have to have so much challenge when it comes to mathematics? Because the calculator, Bantabab, it will only give you what you feed it. So it is very important that before you do anything in your calculator, you understand it. Then we are saying it is basically speed up in the reaction of writing the paper. So it's like in enzymes, in physics, also in lab sciences. So what we are going to look at, briefly, we are going to look at the trick definition of ratios. Then I remember when I was still schooling, and then we were asked this question in trigonometry, and then we were asked to define a ratio. It was problematic. So I also feel that it is also important here that as we are engaging, we are also unpacking such very critical concept. A ratio. What is a ratio? A ratio is a comparison of two or more entities or things, of what? Of the same characteristics. So that is a ratio. You are comparing things. What do I mean by that? So you can compare in class, you can compare boys and girls because both of them are human beings. But what if you are comparing things that are not the same characteristics? We were just informed today that there will be an increase in our fuel, diesel and petroleum. So each and every liter of diesel or petrol will be costing something. And then they said petrol will increase by 3 rand something, whereas diesel will increase by 6 rand something. Then we'll then be told that a liter of a diesel will be 32 rand per liter. You are now comparing two things, money and diesel. So what do we call that? We call that is a rate, because the other one, the amount will increase based on the number of liters of the diesel or petrol. Then that becomes a rate. So on the lighter note, these are very important concepts that as you learn for understanding, you understand them. So also ratio comes very strongly when you are dealing with Euclidean geometry. So it is very important to understand that one as well. So we'll be looking at identities also encapsulating with the reduction. So we have to look at the reduction. Then thereafter we'll be then try to look how these definitions and identities are being applied in the context of questioning and all that stuff. So it is important to look at that one. Wow. I want to believe that we all understand this presentation. And then look at the scale of a bow and arrow people. So the Khoisan people were using this artifact or tools to hunt. When we were actually engaging with my colleagues during our PLC session, we then ask ourselves those questions out of curiosity, obvious, to say, but yes, we are teaching trigonometry, but what is trigonometry? What are the trig ratios? And all those questions enables us to understand the importance of bow and arrow when you are learning trigonometry. But let me not maybe waste so much time on that one. We will see. It was after then this presentation was also came into actually effect, whereby a person with bow and arrow was shooting some actually equation or inequality, if you were to call it like that, because it says which is greater between these two. Then the greater and the less, we look at it when we are looking the inequalities. Sine of 1 degree over sine of 2 degree, and sine of 3 degree and sine of 4 degree. But that was pointed by what? By a bow and arrow, which is an indication that trigonometry has got some relationship with bow and arrow. That is fascinating. As you can see this diagram, now you can see there is an arrow here and there is bow. How this now is integrated in our content. Very fascinating. What is trigonometry? Let me maybe take you there. Trigonometry, try in your lab sciences, in your physics. Actually, trigonometry is derived from what? Greek words, whereby tri, as we all know, means what? 3. What's 3 they're referring to? Gono. Gono means any actually sides of an object or a diagram. So whereby metron means the measurement. So what then does it mean? Basically, trigonometry means it is the study of the measurement of the 3-sided figure. That is trigonometry for us. So that's why whenever you are dealing with triangles, you will be applying what? Trigonometry. So as we all understand that one. But don't forget, I said bow and arrow. They were the ones that actually informed the trigonometry that we are learning today. So the other question that we asked ourselves was, but what is sine of an angle? What is sine of theta? What is sine of A? Oh, mathematics. It was up until we understood that basically sine means what? It's from the line that starts from the circumference of a circle to the other side, which we call it what? We all know that one. We call it what? A chord. And then the word chord comes from a Latin word meaning chordae, just a string. That's what it means. So therefore, sine means half of that chord. So in this case, it can be regarded as a height. So that's what means sine. So it is half chord in relation to obvious an angle. Oh, that's why bow and arrow. It is there. So basically, sine means what? Half of a chord. Again, you will see how we are saying that. So if you look at this one now, here is a unit circle. So with this unit circle in mathematics, they just use a unit circle whereby the radius is equal to 1. What is a radius? That distance, that line from the center to the circumference, they call it a radius. Like as you know, with your radius, whereby the bone comes from the thumb to the elbow, it defines a radius. So in relation to that on a lighter note. So now, using this one, if we found the measurement, remember, the measurement of this side in relation to an angle, we are then saying this height in relation to an angle, which is what? What is this side? It will be sine in relation to an angle. In this case, our angle is theta. Will be then given by opposite over the hypotenuse side, which is y1 in this case, over 1. So therefore, the height of this will be what? It will be sine of theta will be y. So the distance of this will give us the measurement of this height. And then the other question that we ask ourselves, what about then cos? Cos, learners, it's just simply means what? The complement of sine. So if we take this diagram here, we have got theta here, we've got 90 degrees here. What will be this angle? I'm sure we all know. The sum of the interior angles of a triangle, they add up to 108. So to find this angle, we'll say 180 minus 90 minus this theta. It will give us what? 90 minus theta. Therefore, for us to find this distance here, we will be determining the distance that complements what? Sine. So basically, cos means a complement of sine. That's why it's called what? Cosine, a complement of sine. So that is the meaning behind the cos that you actually know. So if we look at this one now, let me take out that triangle there. It is look like that. This is our triangle now with theta here, with 90 here, with 90 minus theta here. I'm sure we all see that one. So let me say we've got x here, we've got y here, we've got r here. I've just indicated here that sine of theta will be equal to y over 1, whereby 1, it is our r. So therefore, if we look at this diagram, sine of theta will be then equals to y over r. What about cos of theta? Cos of theta here, cos, which is complement of theta, will be adjacent. What do they mean by adjacent? Next to that angle. Adjacent means next to an angle, because we know that one will be a hypotenuse side, which is a side that is opposite to a 90 degree, because hypotenuse means below 90 degree. Now, cos of theta here will be what now? X over r, which is now the definition of cos, whereby if our r equal to 1, our cos will be equal to x. What then does it mean? The distance of adjacent side to an angle will be determined by cos. That's what they mean by that. What about the 90 minus? If we look at the 90 minus, let me erase here. If we look at the 90 minus, it is very interesting. So the 90 minus on our right angle triangle, sine, where's my pen now? Sine of 90 degrees minus theta here, we're saying it means opposite. So sine of 90 minus, it will be this side, which will be opposite to a given angle. And our given angle here, it's 90 minus. So sine of 90 minus will be then x over r. X over r. I think we can deduce something here now. Cos of theta, it is x over r. But on the very same triangle, sine of 90 minus theta, it is x over r. So what then does it mean? We can make a conjecture that if cos theta equal to x over r and sine theta, sine 90 minus theta equal to x over r, it means these two are equal because it is x over r and also here it's x over r. Then therefore the conjecture that we can make is that sine of 90 minus theta is the same ratio as what? As cos theta. I want to believe that we all understand what we have just dealt with now. We have dealt with what we call co-ratios. Co-ratios. So that's what we have deduced here. So same thing applies. Cos 90 minus theta. Cos 90 minus theta will be also what? Will be adjacent over hypotenuse. Will be y over r. Adjacent over hypotenuse. So it's y over r. But we also deduce that sine theta is y over r. Cos 90 minus theta is y over r. What deduction can we make now? We can conclude that therefore cos of 90 degrees minus theta is also what? Sine of theta. Why do I have to explain this? It's because with trigonometry and Euclidean geometry, you deal with identities. What you are given is not what you are given, you are giving its identity. So whenever I actually teach this thing, I say, what you see is not what you see, but you see its identity. Meaning that when you see cos 90 minus theta, you don't see that one because of your conceptual understanding. But what do you see? You see sine theta. When you see sine 90 minus theta, you don't see sine 90 minus theta, but what do you see? You see cos theta. That's how these identities work. Pages basically come from identical, meaning what is giving is not what is giving, but it's its identity. So with this illustration, I just wanted to unpack or review the concept of trig ratios. Now, the other question that we actually asked ourselves was the question of, what about then tan? And then just out of curiosity, the other question we ask ourselves is that they say tan is opposite over adjacent, which is the same as sine over cos. Okay? But on the other hand, the word tan means what? A tangent. Then what is a tangent basically? We all know that in mathematics, a tangent means touch at once, which means that line that will touch was set at one point outside. There must be condition. One, it must be on the same direction as the curve or as the circle in this case. If it's in graph, it must be moving on the same direction. Why am I saying that? If we look at this line also, here, it touches our circle at 1. Oh, so do we mean that this line is also a tangent? No. This line has got an ability to cut. It divides the circle. So that is the concept of what? Secant. Because secant means what? You are cut. You are cutting. That is the meaning behind secant. Secant means cut. But tangent means touch outside. Therefore, you should be able to differentiate these two words. Secant means cut. But tangent means you touch at one point. Then how come then a tangent becomes a trig ratio of two lines? Out of curiosity again. So it is very important for us that we also understand that one. I'm giving the foundation so that as you do whatever that you are doing, you understand what is it that you are dealing with. Let us look at this diagram. We have got a line, which we all know it's a radius from the center to the circumference. That is what? A radius. We all know that one. But that line, if it passes through the circumference, it becomes what? A secant. Okay? We have got this line. And this line, I think I've alluded and I've unpacked this one. That line is what? Half chord, because this line from here to here, we know that it is a chord. But if it ends here, it becomes half of that chord. Therefore, it's what we termed it to be our sine. And here we've got another line. And this line, we said it's a complement of sine. And then we said it's what? It's cos. I'm sure we all know that one. Now, when we look at a unit circle, this unit circle, a line from the center to the circumference, which is the radius, being equals to 1, then they will term this diagram a unit circle. Then we've got a tangent outside. And then that tangent touch our circumference there at once. Because it joins a radius, it becomes perpendicular. I think now I'm also touching based on your Euclidean geometry. A line from the center to the circumference, if it's a radius with a tangent, therefore a radius is perpendicular to the tangent. Why are they perpendicular to each other? It's because it defines the shortest distance between a radius and a tangent. The moment you go otherwise, it is no longer perpendicular. Therefore, the shortest distance between 2 points will be defined by a perpendicular intersection between the 2 lines. I'm sure we all remember that one. Now, from here, if we observe very closely, we can deduce something. This is a triangle. Also, this one is a triangle. We are saying the radius of this is 1 unit. And the radius of this is also 1 unit, and it becomes a unit circle. It's for the definition, simplicity in mathematics, to call it a unit circle. Oh, if we look at this angle is common for both triangles, the bigger triangle and the smaller triangle. If this is 90 and this is 90, there are some similarities that we can deduce here. There is a common angle, there's a 90, there's a 90. Oh, in grade 9, we spoke about similar triangles. What are similar triangles? Those triangles that are equiangular, meaning they've got equal angles. So if here we have got A as an angle, we have got 90 and 90 here. So automatically this angle is the third angle of a triangle, they must be equal because all of them, if we add, they must give us what? 180 degrees for each triangle. Okay. What then does it mean to us? We can apply the concept of proportionality. What is then proportionality? Proportionality is the equality. Equality of what? Of ratios. So that's why it was important for us to understand what is a ratio, which can be expressed as A over B, which can be expressed as A maps B, which can be expressed as A is to B. So please be careful of that one. Sometimes whenever we are mentioning the ratio, we actually want to say it whenever we are dealing with coordinates. So in coordinates, we say X and Y because our 2 sides or 2 lines meet. But with the ratio is the comparison. Please take note of that one. So to recall the concept of similarities, this will define a tangent, which is this line. So what can you say about it? In triangle, A, B, C, and triangle A, D, E, we are saying BC, which refer to this tangent, over what? It could be, it will depend how you look at it. It could be over DE, because they must correspond. DE is equal to what? Is equals to AC over AE, over AE. I'm not going to look at the third ratio. What makes us to conclude in this fashion is because we have identified similar triangles. So that's why we are saying now we can put it in a proportionality concept. But if we go back to there in our diagram, we can see that BC was a tangent over what is DE? If we look at DE, it is our sine. It is our sine in this case, which is half chord. I can express as what? As sine of angle A in relation to this A is equals to our AC. If we look at our AC here, our AC is this one. If we go back to our diagram, sorry, Our C will be here. So our AC will start from here at a center. Let me just erase so that we can all see what I'm talking about. If I erase here, our AC, it will be that line. Starting where? Starting from the center to the circumference. So we say if it's a unit circle, which means this will be what? This will be 1. So our AC is the same as 1 over our AE. If we look at this diagram, our AE is halfway. It's where the radius intersect with the chord. So our our AE is this part, which we said in this right angle triangle, it's our complement of sine, which is what? U cos over U cos of angle A. Then our BC as a tangent. Let us replace our BC as a tangent now. Therefore, a tangent which we say tan of A will be then equal to what? Since we have got one term on the left and one term on the right, we can introduce the multiplicative inverse of sine. We multiply by sine of A over 1 and multiply by sine of A over 1 because it's an inverse. So this goes once to this. It will give us 1 and this 1. What is 1 times BC? Is BC, and our BC is what? Is tan of A. What is 1 times 1? It's 1. We don't have to write 1 because 1 is a multiplicative identity. It doesn't change the concept of tan. Is equal to, what is 1 times sine of A? It's going to be sine of A over, what is cos of A times 1? It is cos of A. It is on those bases. Why are we then saying tan of an angle is equal to sine of an angle divided by cos of that angle? I'm sure now we really understand where does this thing of a tangent being the ratio of 2 distances in a right angle triangle come from. Thank you very much on that one. Then we go to the square identity, which is a Pythagoras theorem. The Pythagoras theorem, as we all know, the number of squares in this part of a right angle triangle plus the number of squares in this part will give us exactly the total number of squares. That is the meaning behind the Pythagoras theorem or Pythagoras theorem. So therefore it says c squared is equal to the sum of the other two sides squared in a right angled triangle. So I'm sure we all know that one. It is very important that we understand this theorem because in trigonometry, since we deal with a right angle triangle, it's what we use most. So I have just spoken to a right angle triangle and then its Pythagoras theorem. What then does it say to us? We are saying x squared plus y squared is equal to what? R squared. That it's Pythagoras which says that to us. But we have just deduced now, when we were looking at the trig ratios, that sine of theta as an angle is equal to what? Y. Cos of theta is equal to what? X. I'm sure we all remember that one. So we have to know that y then, sine of sine square of theta plus cos square of theta equals to 1. It's just a recall so that when we're applying, we know what is it that we're applying. So therefore, this one will be what? This one will be y over r all squared plus x over r all squared. Then we apply the laws of exponents. So when we apply the laws of exponents here, we're going to have y squared over r squared plus x squared over r squared. We are adding fractions here. So if we add the fractions and the denominators are the same, we keep the denominator, which is r squared, then we add the exponent. So x squared plus y squared. It is correct to express it like this through a commutative property. When you say 2 plus 3, it will be the same as 3 plus 2, which will be 5, which will be 5. So it is correct. But what is x squared plus y squared? X squared plus y squared will be r squared over r squared, which give us what? 1. So therefore, it is this reason why we say these identities are true. So I want to believe that you are following that one. Now, again, the other identity that I would like us to look at, it's what we have deduced. We have deduced that we also have got what we call the compound. We use the cosine rule and the distance formula to prove that cos of A minus B is equals to cos of A times cos of B. Plus, it changes the sign, plus what? Plus sine of A times sine of B. So this come from what? Come from compound angles. So what does it mean? When you see this, you don't see this, but you see this. Same thing applies when you see this. You don't see this mathematically, you see this. That's why they work identities. Now, they can also ask us to derive the one that has got now cos of A plus B, because here do you see we've got minus B. So how would you use this as you proved it to determine this? So do you agree with me that cos of A plus B can be expressed as cos of A minus into negative B? What is negative times negative? Positive, obvious. So this means this. Now we apply identity number 1 to work out identity number 2. According to identity number 1, says that to us, cos of A times the second angle. The second angle in this case is negative B, which will be what? Which will be cos of negative B. Now we are introducing the negative angles. Negative change to positive, then it was plus. Plus sine of A times sine of the second angle, which is B in this case. Then we simplify. Following those identities, this is cos of A, cos of A. So with the negative angles, we know that it is on the fourth quadrant on a negative direction. That's what it means. So how is cos on the fourth quadrant? X is positive, R will be always because it defines the distance. So therefore, cos will be always positive on the fourth quadrant. So plus here, this plus, it comes from the very same identity that if it was negative, it will be also positive, using the distance formula and the cosine rule. So it's going to be sine of A. So this one is on the fourth quadrant, and sine defines by y. How is y on the fourth quadrant? It is negative because it's below the x-axis. So therefore, it's going to be times negative sine of angle B. Then we simplify. This will be cos of A times cos of B. Positive times negative will be negative. Negative what? Sine of A times sine of B. What then does it mean to us? If you see cos A plus B, you don't see cos A plus B. You see cos A times cos B minus sine A sine B. I want to believe that you're able to also derive this one from the very same cos. We can also use the very same thing to derive the one for sine. We can also use the very same thing, but I'm not going to do that one because of time now. So what I'm going to do is just to recall the identities for sine, and then we look at the double angles, then we apply. So I think I've shown how do we work. So for us to derive the sine compound identity, we use the concept of correlations, which we discussed previously. So that's what we use, because we have seen that sine 90 minus of an angle will change to cos, vice versa. Cos 90 minus will change to sine. Then from that one, you can come up with the correlation, the compound identity for sine. What is the compound identity for sine? I think we all remember. The compound identity for sine, it will be sine of A minus B. It will be given, because of the correlations, it will be sine of A times cos of B. Sine of A times cos of B minus cos of A times sine of B. So how do we get this one? We use the co-ratio, student. Please don't forget that one. It's come from cos 90 minus A plus B, I'm tempted now to derive it because I want us to understand it. So if you distribute this one, what we are going to have? We are going to have cos of 90 minus A, and then minus B. Then we apply the cosine identity. So if we apply cosine identity here, we know that if we actually expand this, let me maybe quickly show it because sometimes they do ask it in our examination and we will have to know. So I'm going to be just quick on this one so that we all understand where do these compound angles come from. It is very important since they are examinable. So this one will be what? Cos 90 minus A, we have seen that it is sine of A. Then times, okay, maybe let me first start with cos so that people will really understand. We said for cos, it's going to be cos of the first angle, which is 90 minus A, times cos of the second angle, which is minus B. Then because it is now negative, it has to change the sign. It is going to be plus sine of 90 minus A times sine of B. So that's what we need to take note. So it changes sign because of that negative. Now let us simplify. If we simplify this, what is cos A minus cos 90 minus A? It's going to be sine of A times cos of B plus, what is sine 90 minus A? It is cos of A times sine of B. So what does it mean? It means this will be, because cos 90 minus A plus B, it is the same as what? As sine 90 plus B. I want to believe that we all understand where the compound angle come from for sine. That's where it come from. So I want to believe that I've explained that one. So maybe now I'm not going to derive this one. I'm just going to write sine A minus B. Based on this one, we know that one now is going to be sine of A times cos of B. Sign does not change. Minus cos of A times sine of B. So this is a compound for sine. So after compound, we must then recall the double angles. So the double angles, student, they come from the fact that if those acute angles are equal, for instance, in a right angle triangle, we could have 45 plus 45 plus 90. So 45 plus 45 plus 90, that will give us what? That will give us 180 degrees, which is then we will be correct. So double angles come from that perspective. So for sine, we must all know that for sine, the double angle for sine, it will be sine of what? Of A plus A. If A is equal to what? Is equal to B. I've just said if it's 45 degrees plus 45 degrees is 90. So this will be what? Sine of A times cos of A plus cos of A times sine of A. So this then will give us that. Sine of A, cos of A, sine of A. I've said through commutative property, it doesn't matter. 2 times 3 is the same as 3 times 2. So these are the commutative property. So therefore, if we've got x plus x, what is x plus x? It is 2x. So if we've got sine A cos A plus cos A sine A, it will be the same as 2 sine A times cos A. So what is A plus A? It is sine 2A. What then it is very important here, learners, what is important here is to observe the pattern in terms of angles. So if we look at angles here, they are doubled by 2. Now from 2 to this A, what is happening? Which means the coefficient of an angle here is 1. The coefficient of an angle here is 1. And then to move from here to there, you multiply by 2. But from here to there, you divide by 2. What do I mean by that? I mean sine of A can be also expressed as a double angle. So how would you express sine of A as a double angle? If you understand the pattern here, it will be what now? It's going to be 2 sine of half of A times cos of half of A. Then we can express it like that. Same thing applies to what? To sine of 3A. To sine of 3A, it can be expressed as a double angle, a double identity, which will be then what? 2 sine of 3 over 2A times cos of 3 over 2A. So please take note on the pattern of the angles. It is very, very important that you understand the pattern. Now, the other thing that we must actually remember, because this one, it won't be part of our formula sheet. So we must remember that if we take, for instance, sine of 2A being equals to 2 sine of angle A times cos of angle A. If we manipulate this by dividing by the coefficient, which is 2 here and 2 here, this and this, because it's one term, it leaves us with sine of A times cos of A. Here we've got a coefficient of 1 because there's nothing. 1 is the multiplicative identity. So 1 over 2, it will be 1 over 2 sine 2A. What do I mean? If you say this, you don't see this, but you see this identity. What needs do you need to take note of? Please make it a point that the angles are the same for us to apply the half angle of sine. So please take note of that one. This is the critical aspect. So please, I want to believe that you are still following. So I'm making sure that we understand the identities before we apply. Because as I said, trigonometry and Euclidean geometry are very easy, actually, chapters, as long as you have understood your identities and your theorem. So the marks, in fact, are in front of you as you are busy with that question paper. So please recall that one. Now, we go to cos. So with cos, if we add two angles, I think we've done that one. With cos, if we've got cos of A, of A plus A, which will be 45 plus 45. This one will give us what? I think now we know it will give us cos of A times cos of A plus, sorry, minus, because it changes the sign. It should be minus there. So it's going to be minus, it's going to be minus sine of A times sine of A. So that's what it will be. Now, what is cos times cos? We are multiplying the powers of the same bases. We keep the base of A and add the exponents. What is 1 plus 1 is 2, which is square. Minus sine times sine, it's also be sine square of A. So what is A plus A? Cos of 2A is the same as cos squared A minus sin squared A. So whenever you see this, you don't see this, but you see this. Whenever you see this, you don't see this, but you see this. Now, again, through identity of cos squared A plus sine squared A equals to 1. Sine squared A can be a subject in this case. Through additive inverse, it's going to be 1 minus cos squared A. What then does it mean? If I see sin squared A, I don't see sin squared A. What do I see? I will see now minus 1 minus cos squared A. So I drop this one down, which is going to be what? Which is going to be cos squared A. This is our cos squared A. Then we simplify. So cos squared A, we distribute this negative 1. So negative times positive is going to be negative 1. Negative times negative is positive cos squared A. Then we group the like terms. What is cos squared A plus cos squared A? It is 2 cos squared A minus 1. So whenever you see cos 2A, you don't see that one, but you see what? A double angle identity, which is 2 cos squared A minus 1. Same thing applies if we manipulate and make cos the subject here. What we are going to have? If we manipulate that one, we are going to have now another third identity for the double angle for cos, which will be then be what? it will be, this cos will be the same as 1 minus sine squared A, according to this identity, minus sine squared of angle A. We group the like terms, 1. So negative sine squared A minus sine squared A is going to be negative 2 sine squared A. So whenever you see this cos 2A, you don't see this one, but you see what? You see 1 minus 2 sine squared A. So please recall again, cos A can be expressed as a double angle identity. You look at the angle, here it was 2, but here it's 1 of A. Therefore, if you want to express it in this one, the example will be 1 minus 2 sine squared. Sine squared what? Half A, because from 2, the relationship from 2 and this one would be 1. So it means we divide this one by 2 to get the other one. So please, I'm just making an example here. So we then actually able to apply all the identities as well as the reduction and the negative angles, of which I want to believe that one will be easy. So don't forget to actually comment on your chat, and then question and answer chat, and then you also make sure that you sign that register. Now, how these identities, they can be applied. So let us look at this one from the November 2024. And then learners were asked to answer this question. And then it says, in the diagram, line OP, if you look at line OP is exactly the same as that radius that we were referring to. It's from the center to the circumference. It is that radius. Therefore, it will be R. It's given with a point, which means on the circumference, there is this point, which is -3 and -4. And this is X and Y. So of that one. So if we look at this one now, we are applying trigonometry. So looking at the given information, it says with KOP being an angle at angle A, so therefore it becomes a reflex angle, as we also recall that one. So based on the given information from the from the point of origin to that point, it says it is -3. Then the height or the distance of that one, it is 4 units, but because it's below, it's on the third quadrant, it's going to be -4. So in this right angle triangle, what we don't have is the distance of R. And R, let us recall, it's always positive because it defines a distance. We then apply the Pythagoras theorem to determine the value of R. How would you do that? We are going to say x squared plus y squared equals to R squared. Our x here is -3 all squared plus -4 all square, which is equals to R square. What is -3 all square? Negative times negative positive, 3 times 3 will be 9 plus negative times negative positive, 4 times 4 will be 16 equals to what? R square. And then 9 plus 16 will be what? It will be 25 equals to R square. Learners, this is R square, is not R. Therefore, for us to determine R, we need to introduce an inverse of square, which is the square root, and also the square root. So when we introduce the square root, the answer will be either positive or negative. Why? It's because the square root means what value must you square, then you get that answer. We know that -5 all square is the same as -5 times -5. So what is negative times negative? Positive. What is 5 times 5? 25, which is the same as 5 squared, which is the same as 5 multiplied by 5. So what is 5 times 5? 25. But because we were dealing with a distance can't be negative. Therefore, we will only take +5 being our radius in this case. So our R is 5. Now, we have got all the sides now of that right angled triangle. Then by doing so, we can now easily answer the questions that were actually submitted to the student in 2024. That's how easy actually is trigonometry, as you can see. Once you know all the identities, it will be very much easy for you to scoop those marks, and then you pass your mathematics with distinction. Because obvious, maths, it's a universal language. It is an easy language to be understood by everyone. So it's a matter of understanding what you are doing. Now it says, without the use of a calculator, determine or calculate the value of What will be then the value of cos of angle A? Learners, the mistake that we can make here is us wanting to find the value of A. No, the question says, what is the ratio of this cos of A? So using the concept of ratio now, we know that cos is defined by x over r. Now, in this case, the distance of x, it will be -3 over our r. We have just calculated, it will be 5. So we have calculated. So it is -3 over 5. Then you have got your 2 marks there. And then the other mark will come from calculating the value of 5 because it was not given. Now, the other question says calculate the value of cos 2a. Cos 2a. See, now we were only giving the value of a, not 2a. How then now do we have to calculate that? It's only if you understand your identities. So your identities, we just recall them now. Cos has got how many identities? Has got 3. You can take any of your choice. We know that cos 2a is the same as 2 cos squared a minus 1, or is the same as cos squared a minus sine squared a, or it is the same as 1 minus 2 sine squared a. Yours is to recall the identities. So I'm just going to take this one because we have calculated the value of a. Be careful again. This square, it's not squaring the angle, learners. But what does it mean? It's a ratio of cos that is square. Meaning that it means that it's cos of angle all square. Therefore, it is the same as x over r all square. So that is the meaning of the notation. Please take note of that one whenever you are dealing with these trig ratios, so that you don't commit they call it silly mistakes. So please take note of that one. So therefore, we can easily then solve this one. It's going to simplify this one. It's going to be 2 into, we have just calculated the cos of A. It was -3 over 5 all squared minus 1. Now, without the use of a calculator. The other misconception that we might have here is to try to simplify this, whereas the highest degree there is 2. You don't do that. You only do that once the highest degree is 1. What then do I mean? We must first simplify this before we multiply by 2. Take that one through your board mass. So it's going to be 2 into. So here everything is raised to the power 2. So -3 over 2 is the same as -3 over 5 times -3 over 5. So negative times negative, positive. 3 times 3, it's going to be 9 over 25 minus 1. So now you can multiply. This is over 1, meaning you multiply a numerator with a numerator and a denominator with a denominator. 2 times 3 will be, so times 9 will be 18 over 1 times 2 will be 25 minus 1. What are you doing here? You are subtracting the fraction. This is over 1. The first thing first, make the denominators be the same. So you multiply with a denominator which is 25 over 25. Now, what are you going to have here? You are going to have 18 over 25 minus 25 over 25. Now you have got the same denominators. If you have got the same denominators, you keep the denominator, which is 25. What is 18 minus 5? So 18 minus 25, I mean, you're left with -7. I'm only going to do the next one as now the assurance to say you can pick any, and then you'll get one and the same answer. So let us see if we have taken the one-off sign. So with the one-off sign, please take note of what we are doing, because I don't want to move from here so that we can see all the questions as I'm doing them. So that is the reason I'm writing and erasing. So please follow what we are doing so that we avoid that one. So the one for sign, cos of 2a is what? Is 1 minus 2 sine squared of a. But what is sine a? Sine a in this information will be -4 over 5. So that will be equal to our sine of angle A. So in this case, it's going to be what now? It's going to be 1 minus 2 into, I think I've explained the meaning behind the square. It's going to be negative 4 over 5 all squared. So that is the meaning, which will be then 1 minus. Please don't distribute before you simplify. It's going to be 2 into negative 4 over 5 all squared will be 16 over 25. Then you can distribute your 2. It's going to be 1. 2 times 16 will be 32 over 25 because this 2 is over 1. Now, again, we have to make the denominators the same. You multiply by 25 on both sides. It's going to be 25 over 25 minus 32 over 25. Now, the denominators are the same. You keep the denominator and subtract the numerators. So what is 25 minus 32? 25 minus 32, again, is going to be it is going to be negative 7. So do you see that we get one and the same answer? It doesn't matter which identity that you use, as long as you understand what you are doing. I want to believe you are still following and you are still enjoying what you are doing. And then 1.3, also on the very same paper, it says, determine or calculate sine of A minus B if it is further given that, which means the one that A we were using is still this one. But now we don't have B on the previous one. I want to believe we can actually follow. We don't have B here. So that's why they are giving us an additional information. They are saying if it's further given that sine of angle B, it is 4 over 5. What defines sine? What defines sine? It is y over r. It means with this information, we don't have what? We don't have x. How will you determine x? We use what we have done. So for us to determine x, we have to use Pythagoras theorem, whereby in this case, let me apply the Pythagoras theorem. Please pay note on this one. I'm applying the Pythagoras theorem. Please be careful of what I'm doing. We know that sine squared of b plus cos squared of b is equal to what? 1. But what is sine of b? It's going to be 4 over 5 all squared plus cos of b squared equals to 1. So this will be 16 over 25 plus cos squared b equals to 1. Through additive inverse, cos squared b is equal to 1 minus 16 over 25. 1 minus 16 over 25. Wow. Okay. So we haven't solved the ratio of cos in this case. We have to simplify. So that will be what? It will be 25 over 25 minus 16 over 25. So here the denominators are the same now. It's going to be 25. 25 minus 16, it's 9. All this is equal to what? Cos squared of b. But we want the ratio of cos. We introduce the square root. This eliminate this because they are multiplicative inverse to each other. So therefore, the square root is the cos b, then cos b will be then equal to plus or minus 3 over 4. That will be the ratio. Sorry, not 4, but 5. That will be the ratio of what? The ratio of cos. Okay? That is super. Now, which one are we taking? There is a restriction. It says that when b is greater than 90 but less than what? 360 degrees. So with that one, we then have to understand that, okay, therefore, it means that our b must be greater than 9 but less than 60. Where sine is positive on the second quadrant. How is cos on the second quadrant? Cos on the second quadrant is negative. So therefore, we must take what? Negative 3 over 5. So that's how we can actually work on that one. Now, let us apply that one now. So what we are going to do now to apply those compound, so we are going to have what? We are going to have the simplified version of that identity. What is going to be? It is going to be expansion of this one. This will be equal to sine of A times cos of B minus cos of A times sine of B. So therefore, what is sine of A? We have calculated previously our sine of A. It was -4/5 times cos of B. We just calculated now. It is times -3/5. Please put the parentheses so that you don't make any mistake. Cos of A. What was cos of A? We have calculated it was -3/5. And sine of B, it was given to be 4/5. So again, what is negative times negative is positive. 4 times 3 is going to be 12/25. What is negative times negative? Positive. 3 times 4 is going to be 12/25. Again, we do the same thing. We keep the denominator, which is 25. What is 12 plus 12? It is 24. So that's how we apply all these identities. I want to believe that you have got a great session. Now you understand how to apply these identities and then all that stuff. So it is very important for you actually to take this one as our homework, so that whenever we are going to come back, we will be doing this one as our homework. It is also the application of the identities that we have just unpacked now. So I'm going to give you this one as your homework. Please write it down so that we will go through as a homework. And then the next one, because I prepared two, the other one actually is this one, which is also be your homework, also followed by this one. So these are the three actually sums that I will request that you do them as your homework, because that's what actually I wanted you to do, so that you see whether you are following on the identities. The first one is this one, you will have to do it. And then the other one, it will be this one as your homework, and then also to do this one. So thank you very much for your time. We want to believe that we have actually a great time, and then now you are ready to go and explore your mathematics, and then you are going to pass mathematics. So see you next time. Thank you very much for the time that you have spent with us in this evening. See you next time. Thank you.